Okay, just wanted to do a quick run through on number 13 from 7.2, which is integrating sine to the fourth times cosine squared. So those are both even powers. And just as a quick reminder, the book has these little sets of recommendations. And this is their recommendation when the powers of sine and cosine are both even. These are functions I really try to emphasize when I teach pre-calc, but a lot of you, well, who knows who you took pre-calc from? Some of you from me, some of you from someone else. But in any case, these two, the sine squared and the cosine squared, going back to the double angles, pretty critical. So we'll use those here. And this one, it says it's sometimes helpful to use the sine x times cosine x equals 1/2 sine 2x. We'll take a look at that one as well. So let's go ahead and start this one. And there's actually two different routes you can take on this, and maybe we'll just kind of do a hint at both of them. So one possible way that you could go with this is to break it up into sine squareds. So let's do that. We'll say sine squared, cosine squared. And the reason we're doing that, of course, is that those all of these things are based on sine squared and cosine squared, not fourth powers. So break it up into squareds. And from here you can apply that. This is one way to go. You can apply that those two formulas that we just looked at to all three of these things. So you can say the sine squared is 1/2 times 1 minus cosine of 2x. And same thing for the next sine squared. It's also 1/2 times 1 minus cosine of 2x. And the cosine squared will then be 1/2 times 1 plus cosine 2x. If you're going this way, you can factor all three 1/2s out. So you get 1/8. And then you get to multiply these three binomials together. And after you do a little bit of multiplication, you get, so I'm going to skip a step or two here. You're going to get 1 minus a cosine of 2x minus a cosine squared of 2x plus a cosine cubed. So you can do that. It's one way to go. And I will say what we've got right now are 4 pieces. One is easy to integrate. Cosine 2x, pretty easy to integrate, just a tiny little u substitution. This one is a cosine squared. And it's not of x, it's of 2x, but the formula works the same regardless. It just says that a cosine squared of an angle, any angle, whatever that angle's called, you can go to 1/2, 1 plus cosine of twice that angle. So for us, that'll take our angle from 2x to 4x. So you could redo this as 1/2 1 plus cosine of 4x, and then that one's easy to do. It's 1/2 and then just a little u substitution. And the cosine cubed is probably the hardest one, but you can break that down into cosine squared times cosine. Sorry, those are of 2x. Cosine squared goes to 1 minus sine squared of 2x. And cosine of 2x, so I'm jamming that in there. But that one can then be done with a u substitution as well. You've got cosine and you've got sines. So I'm not going to finish that off because this is one way to go, but it's not necessarily the way that I recommend. So let's look at going the other direction also. So the other direction starts with that same first breakdown, but then look at the second and third factors, these two right here. So I'm not going to touch that first sine squared, but the second two I can look at as sine x times cosine x squared dx. And then we go back and remember there, it is sometimes helpful to use this identity. Sine x times cosine x equals 1/2 sine of 2x. So I'm going to use that right here. So rewrite this as sine squared x and 1/2 sine of 2x squared dx. That might not automatically look better, but now at least for this sine squared right here, I'm going to rewrite that using the 1/2, using this identity, the first one up here. So that's, maybe I'll move the 1/2 out front. 1/2 1 minus cosine of 2x. There's another 1/2 squared right here. So that's 1/2, 1/2, that's 1/4. I'll move that out as well. So we're getting a 1/8. That's the same, by the way, the same 1/8 that we were getting over here. And then we're just left with sine squared 2x. This sine squared of 2x can be changed into some cosines of 4x. Again, that's kind of using this other version over here on the right-hand side, so I'm going to stay away from that. That would give you another route that you could approach it with. But I'm going to try to stay away from that, and instead I'm just going to distribute. I'm going to say multiply that by 1, and I'll also multiply that by cosine 2x. So I'll get 1/8 integral sine squared 2x minus cosine of 2x, sine squared of 2x dx. Okay, so I think we're basically on the track now. This part, again set up for a u substitution, because you've got sine can be the u, and then the du will be cosine. So that part will be pretty easy. And this part right here can be turned into a 1 minus cosine of 4x, and then an extra 1/2. And then those can be integrated pretty easily too. So those are the two possible approaches on number 13. And I realize neither of them is super obvious. There's a lot of these trig things where you get to dance around a little bit and just see what shakes out in the midst of the dance. But this is definitely one of the trickier ones, so I'm glad that people asked about it. And if you have further questions, definitely shoot me an email.